This is Dr. Martin's third supplemental lecture coming from Chapter 5. We're talking about the biomolecules, or macromolecules as I call them. And we were on the second category of those molecules. We're talking about lipids. So I have three examples, three subcategories. We talked about phospholipids. The next category that I want to talk about are those molecules that are called steroids, and they include cholesterol, progesterone, testosterone. Those are the only three that I'm going to give you. There's several more. Certainly you've heard of cholesterol, you've probably heard of testosterone. Ladies, you've probably heard of progesterone. Steroids are a little bit different than some of the other lipids. They are composed of four ringed structures in this orientation. They have a number of different functions. Cholesterol, which is probably the most important of these, but has the baddest reputation, I guess. This is important because it is found and it's critical for cell membranes. So you do need cholesterol. You just don't need extremely high levels of it. And some people tend to accumulate it in their arteries. But cholesterol is essential for cell membranes. It is also a precursor for hormones, certain hormones, such as progesterone and testosterone. So cholesterol is a very important molecule. It's found in between the phospholipids in cell membranes. Progesterone and testosterone are a different category. These are both what we call steroid hormones. They are essentially chemical messengers that are transported in the bloodstream. Third type of lipid that I want to talk about is shown in the upper corner here, and that is a category that we call fats, or I tend to call them neutral fats. Another name for these is, an older name, is triglycerides. More recent name is triacylglycerol. But in either case, this is the general structure. I don't want you to memorize it. I just want you to know the main components. So, as you might guess from these prefixes, neutral fats are composed of one glycerol molecule that is bonded to three fatty acids. And that's where the three comes from. So up here, this is the glycerol part of the molecule, and each of these that I've circled represents the fatty acids. Now, these are the molecules that we can classify as good or bad fats. There's a lot of research being done on fats and their importance in the diet. So I'll say fats. There's really three subcategories that I want to talk about. And if you were to read here's a nutrition label, you will see, I don't know if you can read this or not, but it'll say total fat, then it'll say saturated fat, it'll say trans fat, and then under that we'll have unsaturated fats, and it might have two subcategories, polyunsaturated, monounsaturated. All right, so unsaturated fats are from plants. These are sometimes thought of as the good fats. They are liquid at room temperature, so this is a little bit of grapeseed oil, which is an unsaturated plant oil. Unsaturated, well, we'll talk about these terms in just a minute. Let me go through. So saturated fats are from animal sources. They are considered, I shouldn't use this word, but the bad fats, or the fats that you should probably take in small quantities. And the last category, trans fats, are another word for these are hydrogenated fats, and I'll call these manufactured fats. They're not from natural sources. All right, so what do I mean by saturated and unsaturated? The long chains of fatty acids here are basically just carbon bonded to carbon, bonded to carbon, bonded to carbon. And in the case of animal fats, all of these carbons have as many hydrogens as possible to make up the 4 bonds that they need. So that's called saturated. So in other words, there's as many hydrogens as we can possibly put onto this molecule. Now, the fat, and actually those are solid at room temperature, and this is butter. So this is a good example of saturated fat. Unsaturated fats actually have double bonds, but some double bonds between some of their carbons, which means that, for example, this carbon has 3, it can only take 1 hydrogen. Same here, only 1 hydrogen. This can take 2. So basically this means that I've reduced the number of hydrogens that I can put on that molecule. So we say that it's unsaturated, which is kind of a strange term, but nonetheless, that's what it refers to. Unsaturated has double bonds, fewer hydrogens. Saturated has a lot of hydrogens. All right, one last category, see if I can get this in, trans fats. Trans fats have a definite link to heart disease and arteriosclerosis. There's been a big deal in the media and also in food marketing. So you might even see labels that say no trans fats. These are fats that have been manufactured through taking a plant oil and putting it at high pressure, high temperature, lots of hydrogens, and creating unusual bonds, I'll just say that are called trans bonds. And for some reason, those types of molecules tend to accumulate in the arteries. Sometimes manufacturers won't put trans fats. They will, in the label of ingredients, you might see this word, hydrogenated fats. Same thing, that's a trans fat. The other thing that the food industry has done is if there is less than a half of a gram per serving of trans fats, they can label it as 0. Sorry about that. So you need to read labels and look for this in the ingredients. And sometimes, obviously, one serving may not be all that you eat. So you might be getting more trans fats than you really think. Okay, I think that's all that I want to say about the fats. And we'll take up the proteins a little bit later.